Ever wonder how Google pulls up your search in literal milliseconds? Or how your favorite app just kind of knows exactly what you want? Well, you're in the right place. Today, we're laying out the absolute ultimate roadmap to understanding the real world of computer science and engineering. We're going to cut right through the hacker hoodies and the Hollywood hype, and we're going to show you what this field actually looks like from the ground up in this explainer. Let's get into it.
Look around you. The modern career landscape has completely transformed. Software is eating the world isn't just some catchy Silicon Valley phrase anymore, it's our reality. Every single company, whether they're doing healthcare, finance, farming, or selling shoes, is essentially becoming a tech company. And that begs a pretty massive question for you. Is software eating your future, or are you going to be the one writing it?
So, why does all this matter? Get this, 35%. That is the massive projected growth rate for software development roles globally between now and 2032. The stakes are incredibly high, but man, the opportunity is even higher. Thanks to the absolute boom in AI, cloud computing, and massive digital transformation, the demand for people who actually know how to build intelligent systems is going through the roof.
Here's our roadmap for today's explainer. We're going to cover the core of computer science inside the CSE curriculum, careers, salaries, and reality, how AI is changing CSE, and finally, is CSE right for you?
All right, let's kick things off with part 1, the core of computer science.
The absolute most crucial thing to understand here is that CSE is this incredibly unique blend of theoretical science and practical art. You aren't just sitting there learning how to type out code. You're studying computation itself, algorithms, data structures. You're learning the underlying mathematical logic of exactly how computers make decisions, and then you're combining that with the hardcore engineering discipline needed to design systems that process information efficiently. At its heart, it's just pure creative problem solving.
And what's truly staggering about this field is the sheer scale. We are talking about over 5 billion internet users globally. Think about that kind of macro-level impact for a second. Every digital service they use, every single app, every website, every time they swipe a credit card securely, all of that was built by computer science engineers. The micro-level code you write while sitting in a coffee shop can literally be used by billions of people around the world. There are honestly very few careers that give you that kind of immediate global reach.
Moving right along to part 2, inside the CSE curriculum.
Let's map out what this actually looks like over a 4-year journey. Year 1 is all about your foundations. We're talking engineering math, physics, basic C programming. You're basically just learning how to think logically. Then in Year 2, you hit the core, data structures and object-oriented programming. This is that aha moment where you realize that choosing the right data structure can literally make your program 100 times faster. Year 3 is the deep dive, algorithms, operating systems, computer networks. This is the year you truly become a software engineer. And finally, Year 4 is specialization. This is the fun part, where you apply everything you've learned to cutting-edge stuff like artificial intelligence, deep learning, and the cloud.
All right, on to part 3, the one everyone's waiting for: careers, salaries, and reality.
Let's bring all this abstract data down to earth. What does a typical Tuesday actually look like for a software engineer? Well, you usually start with a morning stand-up. Just a quick 15-minute sync with your team. Then you get into feature development. This is the highly satisfying part. You're writing fresh code, maybe building a brand new sharing feature for an app. But after lunch comes afternoon debugging. And this is the deeply frustrating reality of staring at broken code for 3 hours, just trying to figure out why a user can't upload a profile picture. Finally, evening learning. Tech moves ridiculously fast, so your day often wraps up by reading technical articles or learning some new framework just to stay relevant.
Now, let's talk numbers, because the financial realities here have massive ranges. Take entry-level salaries in India, for example. A Tier 2 company might start you at around 5 lakhs per annum. A Tier 1 company or a really solid established startup, that jumps to about 8 LPA. But then there's the top tier, the FANG companies like Google, Amazon, or those elite startups. They are throwing down 25 to 40 LPA for fresh graduates. And listen, that massive jump in compensation isn't just about the name of the college on your degree, it's heavily based on your actual proven coding skills, the side projects you've built, and how well you survive their grueling technical interviews.
So it's time for a reality check. What are the trade-offs? Well, the pros are pretty incredible. High earning potential, the ultimate flexibility of working remotely from anywhere, and making a tangible impact on the world. But we've got to be honest about the grueling realities, too. The competition is intense. Thousands of people apply for those top-tier jobs. There's also this immense continuous pressure to keep learning because your skills can literally become outdated in 3 to 5 years. And yeah, you will face deep debugging frustration where you spend days tracking down one single tiny bug. You get massive career freedom for sure, but it demands relentless mental resilience.
Which brings us to part 4, how AI is changing CSE.
Generative AI is completely reshaping the software landscape right now, but let's take a breath and calm some of those fears about AI taking all the jobs. Yes, certain tasks are absolutely being automated, writing boilerplate code, finding basic bugs, generating documentation. Tools like GitHub Copilot can spit out standard repetitive code in seconds. But here's the flip side. Because AI is handling the routine typing, high-level human skills are suddenly way more important. Figuring out system architecture, deciding how to scale an app to 1 million users, defining what the actual problem is, and integrating AI into existing systems, those require human judgment. AI cannot replicate that.
Plus, AI isn't just some tool you use, it's spawning an entirely new ecosystem. It's creating some of the highest-paid, fastest-growing jobs in the entire market. We're seeing explosive demand for AI and machine learning engineers who can build these neural networks from scratch. We've got entirely new titles, like prompt engineers, who design the optimal ways to talk to large language models. You need MLOps engineers to actually get these massive models running in the real world. And, crucially, AI safety and ethics specialists are stepping in to make sure these systems play fair and align with human values.
And finally, part 5, is CSE right for you?
Let's do a quick, honest gut check. Who actually thrives in this field? Well, people who genuinely enjoy logic puzzles, who don't run away from mathematical abstraction, and this is key, people who can stubbornly persist through the absolute misery of trial and error debugging. If you love taking things apart just to see how they work, you're going to do great. But who struggles? Honestly, if you actively hate math, if you'd much rather be working with your hands on physical, tangible things instead of abstract digital concepts, or if you get easily stressed out by vague, unclear instructions, this career is going to feel like a massive grind. Having a real passion for problem-solving matters infinitely more than just chasing a prestigious title or a fat paycheck.
So if you're sitting there still on the fence, here is a concrete, actionable roadmap to test the waters before you commit 4 years of your life to a degree. Number 1, try a free online course. Harvard CS50 or a beginner Python class on Codecademy are brilliant starting points. Number 2, just build something simple. Code a calculator app or a basic little web page and see if the actual process of making it excites you. Number 3, talk to people. Ask current students or working engineers what their Tuesday really looks like. And number 4, jump onto a site like HackerRank and try some basic problem solving. Find out firsthand if this is actually fun for you.
We have covered a ton of ground today. The curriculum, the soaring salaries, the brutal debugging sessions, and the AI revolution. Remember, computer science is not just about typing text into a dark screen. It's about viewing code as your personal toolkit to solve some of the most complex, meaningful problems on the planet. The barrier to entry has literally never been lower, but the ceiling? It's never been higher. So I'm going to leave you with this one thought. Are you ready to build the systems that will shape our digital future? The choice is entirely yours. Take that first step, and let's see where the code takes you.